Hello everyone, welcome back. So we're still talking about hormones. So we just finished talking about the posterior pituitary gland. Now we're going to talk about the anterior pituitary gland. And so you remember this figure, we looked at it before. So we talked about the oxytocin and the ADH. Now we're going to go ahead and move on to the posterior pituitary gland hormones. And the first one we're going to talk about is the TSH here. So two hormones that are produced by the hypothalamus, they're stored in the posterior pituitary. Those were the oxytocin and ADH. And now on the other side, it looks really, really complicated here. The anterior pituitary, also known as adenohypophysis. So look at all these hormones that are being produced here. So we might not talk about all of them depending on, time. But first one we're going to cover here is the TSH. And that's related to your thyroid. So let's go ahead and look at that one. Okay. So the thyroid gland is the one that's going to be underneath this cartilage here. So that's the trachea, the windpipe. And then on here, that's the thyroid gland. Okay, so it's underneath your larynx, and that's kind of going to be kind of a spongy tissue. That's called the thyroid gland. Thyroid gland itself is going to make hormones. So what's happening here is that the pituitary gland and in this case, the anterior pituitary gland makes a hormone that's called TSH, thyroid stimulating hormone. And then that TSH goes to your entire circulatory system. It doesn't do anything to your, hands, fingernails, eyeballs. Nothing's gonna happen. It doesn't do anything because you don't have the receptors that you need. So then it finally reaches your thyroid gland, and which is under your larynx, and then your thyroid gland gets activated. And so once it gets activated, it releases the other chemicals, and those other chemicals are responsible for your metabolism. So that's why it releases this T3, T4. So these chemicals are responsible for your metabolism, and that's why we say that sometimes when somebody can eat all day, whatever they want, they still don't gain weight, and that might be because their thyroid is hyperactive. And it's true, if your thyroid is hyperactive, then it's releasing these chemicals that's making your metabolism go very, very fast. You're going to burn a lot of energy very quickly. And if you can't lose weight, if you eat a little bit and you gain weight, that's also because your thyroid gland is working too slow, and your thyroid gland is working too slow. It's not releasing enough of those chemicals, and that slows down your metabolism, and then you retain your calories that you eat. So it's very hard for you to lose weight if you're tired or your metabolism is slow. So here again, you have the hypothalamus. That's going to, so that's the hypothalamus that's going to control the anterior lobe of the pituitary. And it's going to release the TRH, thyroid releasing hormone, that's going to go to the anterior lobe of the pituitary. And remember that's called adenohypophysis. And that's because the TRH is being secreted by hypothalamus, and then it's going to the anterior lobe, and then it's going to tell the anterior lobe to produce TSH, thyroid stimulating hormone. This is thyroid releasing hormone. And then the TSH is going to release, and that's going to uh, be produced by the thyroid. That's going to be produced by the anterior lobe. And then that TSH is going to go into your blood and reach the thyroid gland, and the thyroid gland will produce the T3 and then T4. So that's all you need to know for this class. Your textbook is going to go in a lot more detail for this. So this is actually called thyroxine. And but for the purposes of my class, you just need to know that T3 and T4 is released by the thyroid gland, and that's what's gonna affect your metabolism. And metabolism again is how fast you burn your calories, and that'll make your temperature high, so it'll make you hungry, and things of that sort. So you don't need to go further than T3, T4. Just know what I just went over in this slide. If you take thyroid gland and you look at it under the microscope, this is what you're gonna see. So there's a solid section here, and then there is a follicle in the middle. So that's a thyroid follicle. So these little cells, they're called thyrocytes and thyrocytes, and that's what's making up the follicle. And the cyte again stands for cell. And then thyroid stands for thyroid. So these cells are in the thyroid gland, and that's basically how it's going to work. We're going to talk about the follicle. You're going to look at it under the microscope, and I'll be asking you to identify thyroid follicles under the microscope and then compare it to the other endocrine structures. So T3, T4 in your body, it can only make it if you have iodine. Iodine is necessary to make your thyroxine. So you need to have iodine in your diet in order to manufacture T3 and T4. And that's why we put the iodine salt. We put iodine in the salt here. And inadequate thyroid hormone stimulate the thyroid gland and causes hypertrophy of the thyroid goiter, known as goiter. So I'm going to show you a picture of that. That's a goiter. So we're going to talk about that now. Okay, so these days people are kind of starting to go away from the iodized salt. They're going to go to Trader Joe's and they get themselves this organic sea salt or pink salt that doesn't have any iodine in it. So I'm not sure why people are doing that, but the idea is not there for the government to control you. That's not the purpose of putting the iodine in salt. It's because you need to make T3 and T4. If we don't have iodine, guess what happens to your thyroid hormone? It's gonna malfunction, and your thyroid hormone is malfunctioning due to the fact that you're not getting right kind of nutrients. And you can develop a goiter if you're not getting the right kind of nutrient. And that goiter is going to be the hypertrophy. Hyper means more. Hypertrophy means the tissue is growing too much. It causes the hypertrophy of the thyroid. So you can develop this grapefruit-sized goiter in the thyroid area, and it's the main reason is that's happening is due to the fact that the diet is lacking in iodine. One of the reasons why people had this, in the past would be maybe they were living in a place that was far, far away from the ocean. And, before we had iodine in the containers in the salt, we needed to get salt from the ocean. So if someone lived in the middle of the continent, they didn't have access to the salts, then they were more prone to develop stuff like the goiters. And then the reason why people developed these spice routes were because they had to get these really, really rare vitamins from the sea to the center part of the continent. And then back then, salt was so you know it was so scarce that it was known as a used as a currency. This is where the term came from, that you're worth your weight in salt. That's where it came from, because salt was actually money. They used to pay for stuff. So if you think about the word for salt in Spanish, it's SAL, sal. And then so the word for your payment is salary, and that's where it's coming from. The root word for salary is sal. So salt used to be very, very difficult to get, and now it's everywhere. We have the opposite problem now. We have too much sodium in our food, and that's causing to develop hypertension and things of that sort. This is due to diet, but due to your genetics, your body can have autoimmune disease where your own cells can destroy the cells of your thyroid. If you have autoimmune disease, your cells are going to be um, attacking your thyroid and might become hyperactive. If your thyroid becomes hyperactive, this is called hyperthyroidism. It's overactive thyroid gland. So a hypothyroidism, that your thyroid is reacting to being attacked, and that's then it's going to crank out the T3, T4. It's going to speed up your metabolism. When your metabolism speeds up, you're hyperactive, you're nervous, you have agitation, and weight loss happens. So, and you're also always hungry. And the term BMR stands for basal metabolic rate. So it increases your basal uh, metabolic rate. And if you're not exercising, you're just sitting there, how fast is your metabolism going to see? Basically, there's a baseline for your metabolism, and then the names for the diseases. If you have hyperactive thyroid gland, you have Graves' disease, and that's autoimmune disease. And this is going to fight your thyroid gland, and you could develop a little bit of goiter. And other symptoms would be your eyeballs, they start to bulge out, bulging eyes, and there's a little bit of goiter. And there are some celebrities that had Graves' disease, and they're characterized by having bulging eyes, that were, or they were very agitated or nervous, that kind of behavior. So one famous one was, I don't know, maybe you know this person, maybe you don't. Rodney Dangerfield is a comedian. So he had these bulging eyes, and he was kind of shaky, and these symptoms are symptoms of hyperactivity and nervousness and agitation. Another person might be JFK. So if you look at some pictures of JFK, his eyes were bulging. So we think that he might have had Graves' disease. And by the way, if someone suffers from this um, disease, then the treatment is radiation. And they also do this with your cats and dogs. So if your cats and dogs are diagnosed with having hypothyroidism, and maybe even they or hypothyroidism. So for hypothyroidism, they'll treat it with radiation. They'll give a form of pills. You take these pills. The radiation goes all the way, um, in your body, and it's gonna go and concentrate in the thyroid area, and then it's going to kill these cells that are damaging you. The way it works is you're basically shunned from the society until you poop out the radiation. They give you the pills, then they have you check into your hotel because you can't be near family members, and then you take your pills and you wait until it pops out or you poop it out, and then you measure yourself with um, you know, until you're clear, I guess. So then you can go back into the society, interact with people, but you have to wait until the radiation pills come out of you. So if you have a dog and a cat, then they're going to go through this treatment, and they have a special facility where they get isolated until they poop out the radiation. And then they can go back home. So let's take this thyroid gland, that's your thyroid gland, and flip it. And if you flip it, you're going to look over it from the posterior side. And if you look at it from the posterior side, you have these four nubbins here. You have this one, that one, and this one. These are your parathyroid glands. Parathyroid is on the posterior sides of your thyroid gland. These are going to secrete a hormone called PTH, parathyroid hormone. So you probably have heard about parathyroid hormone, and you probably heard about it earlier in the semester when we talked about the calcium. So PTH goes to your intestines. It tells your intestine to absorb calcium. And even though you drink milk and you eat cheese, you can take calcium supplements. It might not be absorbed by your body or your system if you don't have PTH. So your parathyroid gland is going to produce PTH. And if it's not functioning well, it doesn't matter how many dairy products you're eating, your body's not going to absorb it, and it's not going to your kidneys. And then it's going to your kidneys, and then um, and your intestines. And if you have PTH, then you're gonna absorb the calcium, and you're gonna prevent it from being peed out in your urine. So that's basically what's gonna happen. The PTH is going to stimulate your kidneys to produce a second hormone, that's called calcitrol, which will increase intestinal absorption of calcium ions. And then your intestines will absorb the calcium. So this is what it looks like under the microscope over here. You can clearly see that there's a, thyroid follicle here. And these are the thyroid follicles. And on the exam, I will ensure that you have a slide that's showing you the thyroid follicle. And next to the thyroid follicle, you have this very large thing, and that's going to be your parathyroid gland. So that'll be the landmark of telling you what you're looking at. Next to the thyroid follicles, you're going to have the parathyroid glands. And these are going to be parathyroid cells. So here, parathyroid cells. So you're going to see that next to the thyroid gland or thyroid follicles. So it's going to have all these follicles surrounding it. And then you look at the parathyroid gland, and when you zoom in on it, you see parathyroid cells. So you're going to have both of them on the same slide. That's what's going to help you to identify it. Okay, so we were working on the thyroid gland. Let's see. Let's go back to that image that we were looking at earlier. So we did the thyroid, and let's go ahead and do FSH and LH next. So that's what we're gonna do. We're still working on these hormones in the pituitary. So in the pituitary next we have FSH and LH. So first of all, let's see what these stand for. So the FSH stands for follicle stimulating hormone. So that's FSH. And then LH stands for um, luteinizing hormone. So these are two reproductive hormones. They're responsible for growth, development, and function of ovaries and testes, males and females. So they're produced in both by boys. It's produced in both boys and girls, men and women. They're both found in both sexes, and they have multiple effects. They're going to be basically your steroids. So during puberty, we're talking about puberty, and when the hormone kicks in, that'll cause you to start changing your body, and it's gonna be luteinizing hormone that does that. So it's gonna start. It's being secreted by puberty. At puberty, and puberty is going to vary. In some kids, it starts early. At age of 8, 9. So they start a little bit early, but sometimes they start a little bit later than other kids at 12 or 13. I've heard that in North Korea, the average age for puberty in girls isn't until they're 17. So then looking at a lot of papers from anthropology, looks like um, the age of puberty has actually been going down. Our ancestors, they had age of puberty a little bit later. So it's going down. And in certain places like North Korea, maybe the nutrition's not as good. It looks like in those countries, the puberty age is a little bit later. So at 15 to 17 years old. So at this point, FSH starts being produced by the anterior pituitary, and that's going to go to your muscles, your bones, and it's going to cause them to change. And basically, that's how you're able to develop the shape of a woman and the shape of a man. And in men, we have strong jawlines. In women, you have soft jawlines. In women, you have memory glands. And men, you don't have that, and so forth. And men have deeper voices. So that's all caused by FSH. So one of the weird things that can happen in little baby girls, newborn baby girls, they can menstruate. And you might be surprised by this, but that means there's a hypersecretion of FSH in the newborn baby girl. And the FSH is going to go to the uterus if there's hypersecretion, and it's gonna, do its thing, which is menstruating. So you can literally have a newborn baby girl menstruating. And what needs to be done then for intervention? You send the baby girl to an endocrinologist, and they will have medication to suppress the FSH. And so if you want to suppress the FSH, then the baby girl won't menstruate. So then they can decide when they want to, or when they choose to go through puberty. So when they decide to go through puberty, they stop taking those pills or the medication, and the FSH will start being produced again, and then they'll go through puberty at appropriate age. So that definitely can happen. And then you know, so this the puberty will continue over the course of several months or even longer and years. So eventually you get to sexual maturation. And if you got varying, we got varying levels of FSH in men and women. So you have a combination of other hormones like testosterone, estrogen, and combination of these will develop a person into a male form or a female form. The LH is has to do with the ovaries. So LH is luteinizing hormone responsible for ovulation, and that's so this one is luteinizing hormone is responsible for ovulation. You can write that down if you want to. And this hormone goes in the walls of the ovaries, makes the walls weak, and then when the walls are weak, then the egg can shoot out, and that's ovulation. So it has different effects in men. I'm not gonna talk about that right now. Let's just say that FSH and LH are two reproductive hormones. So that's what we're gonna focus on, and I'll talk about it a little bit more when we get to reproductive structures lecture. Okay, so we did the TSH, we did the FSH, we did the luteinizing hormone. Next, I'm gonna do the growth hormone. I'm not gonna talk about the prolactin. Maybe I'll do another lecture for the ACTH. Prolactin is basically um, it's for lactation, producing milk. ACTH is pretty complicated one, so I might do a different lecture on this. So let's do the growth hormone next. Um, so the GH stands for growth hormone, and as long as you're producing growth hormone um, at the correct levels, you're going to grow at your natural height. If you happen to have a brain that's hypersecreting it, maybe you're producing it too much GH, then you're going to be too tall, like this person in this picture. That's hypersecretion. If you have hyposecretion, means you are going to, you're not making enough. There's the amount is lower than the normal range. Then you're going to be too short, and you're going to be considered a dwarf or a little person. If you go into Guinness Book of Records, look at all the people that have held records for being shortest. They had hyposecretion of the GH, and all the people that have held the records for being the tallest, they had hypersecretion of the GH. And you can manipulate this hormone. For example, if you go to a country where you pay the doctors to give your medical care, you can go to a country, they can inject you with a GH. So as long as you're a child, they can inject you with the GH, and they'll give you a little bit of extra inch, a couple extra inches in your height. So sometimes if they inject you with too much of GH, then the head will be a little bit too long and they look a little bit weird. Maybe the arms and legs might not be proportional. So I wouldn't advise doing it, but if you're in a really extreme situation where the body's not producing enough, then in the United States, the endocrinologist will go ahead and prescribe you with the GH, and you can give that to the child, and so they can get a sort of normal height. So that's another hormone that's being produced by anterior pituitary. So let's go ahead and get away from the brain for a bit, and then we're gonna head over to the kidneys. So we're gonna go ahead and focus on this part of the kidneys, and uh, um, that's called the adrenal gland, or if you remember, I told you they're also called suprarenal gland. And you need to know both, and I'll tell you why. So renal refers to the kidneys, and then supra means above. So suprarenal gland is going to be the gland that sits above the kidney. So these are your kidneys here. And on top of that, you have the suprarenal glands or the adrenal glands. So once you cut into it, the suprarenal glands, you have the outer portion and you have the inner portion. The outer portion is called the cortex, So this part is called the cortex, and the inner part is called medulla. So you have these two terms. Cortex refers to the outer layer, bark of the tree, to the outer layer, and the medulla refers to the middle part. What we call them, adrenal cortex and adrenal medulla, because you also have these terms in other parts of your body. So I just told you that they're called suprarenal glands. That's what your book is calling them, but the old name was adrenal gland. So these are not called suprarenal cortex and suprarenal medulla. They're still called adrenal cortex and adrenal medulla. That's the reason we need to know both of the terms. So this is a cartoon drawing, and this is what it looks like under the microscope once it has been stained. So the adrenal cortex is all this stuff on the outside. So maybe I can use a darker color. So it's all this stuff on the outside. That's adrenal cortex. And so that's the cortex, and I highlighted that in a different color. And the reason we need to, again, separate the adrenal cortex from medulla is that they produce different kinds of hormone. Adrenal cortex, it produces a hormone called aldosterone. So aldosterone here. It's going to regulate the blood pressure and iron levels. It's going to affect your urine. So it's going to affect your urination. So aldosterone is similar to ADH. So if ADH is to conserve water, aldosterone is also to conserve water. So it does something similar. So ADH, by conserving water, is going to regulate your water levels and your blood pressure and all that kind of stuff. And the amount of water you have in your circulatory system is going to affect that. So in addition to aldosterone, it's going to have other hormones called cortisol, cortisone, and corticosterone, however you want to say it. And those are the ones that respond to stress. So basically, cortisol is a stress hormone. Cortisone is basically a molecular configuration that's similar to cortisol. So all three of these over here are going to be the hormones. And I want to say this, that these hormones are not the ones that cause you to stress. These don't cause stress. Just because you have cortisol doesn't mean it's making you stressed out. So what's happening here is that something in the environment is causing you to stress out, it's causing you to become stressed. Maybe studying for this class, it's a lot of materials and it's causing you to stress out. So your body is trying to reduce that stress by producing these hormones. So producing cortisol, and then cortisone, cortisone, cortisol, and corticosterone. These are going to be produced in response to the stress that's being caused by the external environment to your body. So it's trying to stimulate the parasympathetic nervous system by taking you away from the stress. So we call these stress hormones because if you analyze your spit or your urine, you find these there, then you can detect cortisol there. That means your body's stressed out at that time. But if you got chronic stress, meaning you take multiple samples over a period of time or over a long duration, and cortisol is there the whole time, then your body's suffering from chronic stress. And the effects of stress, you're going to have hypertension, you're going to have maybe losing your hair, anxiety, difficulty concentrating, so all that kind of stuff. So cortisol is released in your body when you have stress. So it's trying to relieve the stress. It's not causing your body to stress out, okay? So another one that's going to be androgen. So, andro refers to male. So the word andro refers to male. And so androgen refers to kind of testosterone, which is a type of hormone that's going to make people have male-like features. So androgens are produced in both males and females, and they both have estrogen and testosterone. So you just have different levels. So if you're going through a transition, you're transitioning from female to male, you're going to go ahead and go do androgen injections. That's going to cause male-like features, body features. So the androgen is testosterone. So if you got a dog and a cat and they are spayed or neutered, let's say you go ahead and you fix your male dog by taking away the testicles, and that's what's making the testosterone. The male dog is still going to have sexual behaviors, and the reason is because even though you took away the testicles, it can still produce testosterone from the adrenal gland or the adrenal cortex. It produces a little bit of androgens, and because of that, male dog or cat can still have sexual behaviors. So that was the uh, adrenal cortex. And then we have adrenal medulla. So we're gonna head into the middle part here. So this is the adrenal medulla in the middle. So I'm gonna try to highlight that as well. So that's the medulla, adrenal medulla. So that's going to be producing adrenaline, and this is a chemical name for adrenaline is epinephrine, and norepinephrine is noradrenaline. So that's what's being produced in the middle part. So epinephrine, so adrenaline is like the generic word for epinephrine. It's very similar. The other configurations of epinephrine is norepinephrine, but they both pretty much do the same thing. So this guy here is going to stimulate your sympathetic nervous system, your fight or flight response. So if you get hit with the EpiPen, that's going to cause your heart rate to go up. If your heart rate is going to be faster, and it's going to cause your blood pressure to go up, your senses are heightened, and all that kind of stuff. So all that comes with the fight and flight response. So um, that's happening from the middle part of the adrenal gland, adrenal medulla. It stimulates your sympathetic nervous system and fight or flight response. Okay, so the pancreas is this kind of fatty tissue that is looking, that's behind your stomach. Looks like a fat there. It has two functions. One is exocrine, the other one is endocrine. The exocrine is going to make digestive enzymes. The endocrine is going to make chemicals that go um, and produce hormones. So exocrine is going to make chemicals that will go into your digestive system, and that is going to take the enzymes from the pancreas, and those enzymes will get dumped into intestines. That's going to be exocrine function. It's going to help with the digestion. The other function is going to be endocrine. The endocrine is going to be for the hormones. So there are going to be cells there that are going to produce hormones, and those hormones are going to be the glucagon and insulin. Those are the main hormones that regulate your blood sugar. So when you look at the histology, there are going to be special cells. They're called pancreatic islets. They produce hormones. These pancreatic islets, also known as islets of Langerhans, is what's going to produce the hormones, and it's the other part is going to produce the other cells there are going to produce the enzymes for the digestion or the chemicals that neutralize acid in your stomach. This is the pancreatic islet. This is a histology. So this is what it looks like, pancreatic islets. And I said the old name for it is the islet of Langerhans. This is named after the person who discovered it. So I'm not sure where the term came from, but the word islet sounds like an island. So if you were to take this slide and put it under the scanning lens of the microscope, and you start scanning the slide, you will almost see these little islands on the slide. So that might help you maybe remember it. Island stands for pancreatic islet. And so that's where it's coming from. So the islets of Langerhans is the old name. Your book is trying to move away from the proper names, but a lot of the old literature, a lot of the literature is still calling it that. So pancreatic islet is going to secrete your hormones, and the hormones that's secreting it's glucagon and insulin. So the insulin job is to lower your blood sugar levels. Like I said before, the opposite of it is glucagon. That's going to raise your blood sugar. If you're fasting, your liver is so it's going to secrete glucagon, and then it's going to cause your liver to secrete blood sugar, and that's going to raise your blood sugar. So insulin lowers your blood sugar, Glucagon raises your blood sugar. And the third one is there, somatostatin, and it's going to block glucagon and insulin and has lots of other functions. So I'm not going to talk about that one. Um, so the main ones to remember here is glucagon and insulin. So you just focus on these two.